Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be continuing our discussion on Section 7 of Chapter 1, but this time we're going to focus on absolute value inequalities. So we have 6 examples that we want to do today. So let's take a look here at our first example. Example 1 says the absolute value of x is less than 3. So what I'm going to do is basically treat these like normal absolute value equations, and then I just have to graph my final answer. So if the absolute value of x is less than 3, what I'm going to do, since the absolute value is by itself, is I'm going to rewrite this to say x is less than 3, or I also have to say that x could be greater than -3. So kind of like when we solved an absolute value equation, how we had to set it equal to both the positive and negative. But what we do with inequalities is that we keep the symbol the way that it is with the number given, so x is less than 3. And then when I change the sign, I have to flip it so it's x is greater than -3. And then we're going to graph it. Now I think we're pretty good at graphing, so I'm going to let us cheat on the graphs, and all I want you to do is write these two numbers close to where they'd be on a number line. So -3 would be on the left, 3 would be on the right, and then we need to put our circles. In this case, they're both open. And then we need to shade the respective locations. So it says x is less than 3, x is greater than -3. So we'd be shading right between these two numbers. It's less than the one, but greater than the other. So now let's take a look at example 2. Example 2 says the absolute value of 4x minus 175 is less than or equal to 21. So just like when we solve an equation, we want the absolute values to be by themselves. In this case it is. So I'm going to rewrite my two equations. One where what's on the inside, 4x minus 175, is less than or equal to 21. And one where what's on the inside, 4x minus 175, is greater than or equal to -21. So again, when I rewrite this so I have a positive and negative, I've got to flip the symbol when I change the sign. So this is now greater than or equal on the right. Then I'll solve each inequality. So for this one, I'm going to add 175 to both sides. So we'll have 4x with 196, and then divide the 4. So x is less than or equal, 4 goes into 196 49 times. So we'll say x is less than or equal to 49. My second inequality, if I solve that one, I'll add 175 to both sides. So I will have 4x. -21 plus 175 is going to be 154. And then divide by 4. So I'll have x is greater than or equal, and 4 goes into 154 38.5 times. So once I solve my inequalities, I need to graph them. Again, I'm going to let you cheat on the graphs. We want to put 38.5 on the left I'll say it was that tick mark. And then I want to put 49 on the right. This one, both of them would have the closed circles. And then we want to shade, so we are less than 49 but greater than 38.5. So it's going to be right in between these two numbers. So like solving an equation, but you also have to graph your answer. Our third example says the absolute value of 3x minus 6 is greater than or equal to 9. So I want to slide this over so I can have more room to focus on example 3. And what we're going to do is, since the absolute value is all by itself, we're going to take what's inside the absolute value, 3x minus 6, and we're going to say that's greater than or equal to 9. And then we're going to set up our second inequality, 3x minus 6. And now this time I'm going to flip it to say is less than or equal to negative 9. And then I solve each inequality. So for the one on the left, we're going to add 6 to both sides. So we're going to have 3x with 15. And then divide 3. So x is greater than or equal to 5. For the second equation, or inequality I should say, we're adding 6 to have 3x. Negative 9 plus 6 is negative 3. And then we're dividing 3 on both sides. So this inequality says x is less than or equal to negative 1. So once I have my inequalities, I want to graph it. I'm going to move this up a little bit so we can see the graph better. And again, I'm letting you cheat on your graphs. So we're going to put a negative 1. We're going to put a 5. And what we're going to do is put our circles. Since these are or equal to's, both of them are going to have a closed circle. And then I need to shade, so I'm greater than or equal to 5 or less than or equal to negative 1. So I'm greater than 5. I'm less than negative 1. So now let's take a look at our next example, example 4. So example 4, the absolute value of 4x minus 12 is less than or equal to 20. So for this problem, the absolute value is all by itself. So I'm going to set up my two inequalities. I'm going to say 4x minus 12 is less than or equal to 20. Or 4x minus 12. I'm going to flip this so it's greater than or equal to negative 20. And then solve each inequality. So we're going to add 12 to both sides. So we'll have 4x with 32. And then divide by 4. So we have x is less than or equal to 8. For the second inequality, I'm going to add 12. So I have 4x with negative 8. And then divide by 4. So I'm going to have x is greater than or equal to negative 2. So once I get my inequalities, then I want to graph it. So I'm just going to put a negative 2. I'm going to put an 8. These are or equal to, so both of them get a closed circle. And then I need to shade, so I'm less than 8, but greater than -2. So that would mean we're shading right between these two numbers. And that would be the solution to the problem. Our fifth example says the absolute value of x plus 7 is greater than 16. So what we want is we want the absolute value to be all by itself on one side of the inequality. In this case, there's a plus 7 with it, so I need to subtract 7 on both sides. So I'm going to have the absolute value of x is greater than 9. Once the absolute value is by itself, I'll set up my two inequalities. I'll say x is greater than 9, and I will also say x, flip the symbol, is less than the negative of that, so -9. So once I have my two inequalities, x is greater than 9, x is less than -9, I'm going to graph them on the number line. So let me move this up a little bit so you can see. We're going to put -9. We're going to put +9. Both of these would get an open circle because they're not or equal to. They're strictly greater or less than. And then we're going to shade the appropriate directions. So greater than 9, I'm going to shade to the right from this circle. And less than -9, I'm going to shade to the left from this circle. And that would be our solution for this problem. So now let's take a look at the next example and our final example, example 6. So example 6 has -3 times the absolute value of 6 minus 3k minus 10 is less than or equal to -82. So we have to get the absolute value by itself. So remember my trick, I like to think about the absolute value part as if this said -3 x minus 10. How would I get the x by itself? Would I get rid of the -3 first or the -10 first? If you said you would get rid of the -10 first, that would be correct. And we're going to do the same thing when we see these absolute value inequalities. So we need to get rid of the -10 by adding 10 to both sides of our inequality. So we're going to have -3 with the absolute value of 6 minus 3k and a -72. Now we have to get rid of the -3. So remember, we don't distribute that in. What we do instead is just divide by what number's on the outside. So I'm going to divide both sides by -3 to have the absolute value of 6 minus 3k, and -3 into -72 would be a grand total of 24 times. Now what we cannot forget is the golden rule of inequality says anytime we multiply or divide by a negative number, like we just did with the -3s, we have to flip the inequality symbol. So this would be the absolute value of 6 minus 3k is greater than or equal to 24. And then we would solve this like we have the previous examples. So what we're going to do is set up two inequalities. I'm just going to slide over to the left a little bit more to make sure we got enough room. So our first inequality will say 6 minus 3k is greater than or equal to 24. And the second inequality would be 6 minus 3k is less than or equal to -24. And we want to solve each one. So I'm going to subtract 6 on both sides. So I will have -3k with 18. And then divide -3. So k with negative 6. Now again, you must remember the golden rule of inequalities. We just divided by a negative again. When you divide by a negative, you've got to flip that symbol. So we're going to flip this to say k is less than or equal to negative 6. Solving the other inequality, subtracting 6, we get negative 3k with negative 30, and then divide the negative 3. So we would have k, we would have 10, and then we divided by a negative again. So dividing by a negative with inequalities, we've got to flip the symbol. So we would have k is greater than or equal to 10. So k is less than or equal to negative 6. K is greater than or equal to 10. Now we just need to graph that on our number line. So I have negative 6. I have positive 10. Both would get a closed circle because it was or equal to. And then I need to shade what my inequality says. It says we're less than negative 6, so that'd be to the left. And then we're greater than 10, so that'd be to the right. So our final answer, k is less than or equal to negative 6. K is greater than or equal to 10. And there's the graph to show what that looks like. This concludes our lesson on solving absolute value inequalities. If you have a question, please ask Miss Brooks. Otherwise, I'll catch you next time on your Daily Dose of Math with Miss Brooks.